nuclear power, supported by some, despised by others, seen as an innovation for the world at hand, or another of mankind's attempts to destroy the planet. This alternative energy brings about a heated debate whenever brought up, yet many people don't understand what nuclear power is, its positives and negatives, and how it can impact the world. Late 1800s, Pierre and Marie Curie determined that uranium minerals emitted invisible radiation capable of passing through solid objects. Subsequently, it was determined that the radiation was a result of atomic disintegration, or decay. These experiments eventually led to Marie Curie's premature death but had a significant impact for the discovery of nuclear energy. Nuclear power was conceptualized after World War II. The idea didn't get off the ground due to costs, design issues, and perceived risks in investing in new energy. In the early 1970s, Middle Eastern conflicts such as the Yom Kippur War caused oil prices to skyrocket. As such, investment in nuclear power increased and the plants started getting produced. In nuclear fission, an atom splits into two or more smaller nuclei along with biproduct particles, such as neutrons, photons, gamma rays, and beta and alpha particles. This is an exothermic reaction. On the other hand, nuclear fusion can occur when extremely high temperatures are used to force nuclei of isotopes of lightweight atoms to fuse together, which causes large amounts of energy to be released. Whether or not an atom's nucleus is unstable depends mostly on its number of neutrons. When isotopes of uranium and plutonium undergo controlled nuclear fission, the resulting heat produces steam that spins turbines to generate electricity. The uranium oxide consists of about 97% non-fissionable uranium-238 and 3% fissionable uranium-235. The concentration of uranium-235 is increased through enrichment process. Control rods in emergency situations slow down reaction to minimize fission. After spent fuel rods are cooled considerably, they are sometimes moved to dry storage containers made of steel or concrete. Scientists disagree about the best methods for long-term storage of high-level radioactive waste. There are several proposed options, such as burying it deep underground, shooting it into space, burying it in the deep ocean floor that is geologically stable, or changing it into harmless or less harmful isotopes. When a nuclear reactor reaches the end of its useful life, its highly radioactive materials must be kept from reaching the environment for thousands of years. At least 228 large commercial reactors worldwide, 20 in the United States, were scheduled for retirement in 2012. However, many reactors applied to extend their 40-year license to 60 years. Aging reactors are subject to embrittlement and corrosion. The pros and cons of nuclear power. Pros: large fuel supply, emits 1/6 as much CO2 as coal, and moderate land use. Cons: cannot compete economically without large government subsidies, low net energy yields, catastrophic accidents can happen such as Chernobyl, and no widely acceptable solution for long-term storage of radioactive waste and decommissioning worn-out plants. Trade-offs: coal versus nuclear. Coal: ample supply, high net energy yield, very high pollution, high CO2 emissions, high land disruption from surface mining, low cost without huge subsidies. Nuclear: ample supply of uranium, low net energy yield, low air pollution mostly from fuel reprocessing, low CO2 emissions mostly from fuel reprocessing, much lower land disruption from surface mining, moderate land use, and high costs, even with huge subsidies. There's two major drawbacks from nuclear energy. 1. There's no widely acceptable solution for long-term storage of radioactive waste and decommissioning worn-out plants. 2. Catastrophic accidents can happen with high environmental impact. Along with the negative stigma of anything nuclear, leads to the unpopularity of this alternative energy source. This is an emotional obstacle in which the populace is unaware of the difference between nuclear power and nuclear weapons. The largest expense for nuclear power plants is not the building of the power plant itself, but getting through all the regulations the people impose because they're afraid. Many safety regulations are good, but this process can take up to 20 years. Imagine buying a car now and being told you couldn't drive it for 20 years. This is why no new reactors have been built in the US for 25 years. Unfortunately, coal-burning power plants dump hundreds or thousands of times more radioactive waste into our air and soil than a nuclear reactor would.